At a recent panel on empirical software engineering at the 2013 European Software Engineering Conference, Andrei Terekov raised the question of whether any concrete empirical results determine whether text or visual models are more effective for specification purposes. Sadly, even though this is a frequently asked question, it has no simple answer. A few years ago, we had run an interactive session at the annual Requirements Engineering Conference to draw attention to this issue. We wanted to search for the single, most versatile, comprehensible, expressive, and all-round useful modeling technique to have in our toolbox. We wanted to discover and crown RE's next top model. Through a series of tasks, we challenged our RE colleagues to stand up for their preferred approach to requirements modeling. 7 teams representing ISTAR, URN, which stands for User Requirements Notation, Plain Old Text, UML, Rich Pictures, Information Flow Modeling, and Formal Methods accepted the task. In preparation for the event, each team received the following letter from a fictitious client.
The Gotham City fire engine dispatch system is 25 years old and needs replacing. It has no documentation, so after speaking to my dispatch operators, fire crew, and the general public, I think I have a good grasp of what the problems are with the current system and what we need to do to update it. Please consider my observations. When an emergency call comes into our dispatch center, our dispatchers fill out an online form to collect incident information from the caller. Our dispatchers aren't happy with the many questions they need to ask and loathe the text-based green screen user interface. Nonetheless, the system logs all the information they need and presents the dispatcher with a list of nearby ladders or firehouses, along with resources and associated phone numbers. This is tricky when the dispatcher can't understand the caller and enters incorrect or imprecise location information. Fortunately, each dispatcher has an amazing grasp of GC geography and landmarks and is trained to make a decision on the nature and urgency of the incident, so he or she is entrusted to call up the inappropriate ladder and request dispatch. If the ladder has all its required resources out responding to other emergencies, then the dispatcher has to call the next ladder, and so on, and this leads to a lot of delays. Also, if the incident is a huge one, then it's a dispatcher's responsibility to ensure that sufficient resources are deployed to match the needs of the incident. It's a stressful job, and we're having trouble retaining our staff. The training takes time and the cost is considerable. I could tell you much more, but I've written the rest of my problems in my brief.
The challenge was to see how well the team's chosen modeling technique would lend itself to expressing a complex problem situation. Each team gave a 3-minute pitch in which they presented their previously prepared model and then answered questions from the client. The audience voted on the performance and then selected 4 teams to move on to the next round. Having seen how well the modeling techniques presented the big picture, the client then wanted to see how they handled the specifics. Each of the 4 remaining teams had 10 minutes to either adapt an existing model or create a new one to respond to the following brief from the client.
Last Thursday, Mrs. Middling called emergency services and reported a crisis at 300 Gotham Street. The dispatcher established that her cat was stuck in a tree. The dispatcher sent a minimal crew from ladder 8, that was the nearest one available, in a fire engine with a ladder of sufficient length to retrieve the cat. While en route, Mr. Donino called to report that he was learning how to use a blowtorch to make creme brulee, and there was now a fast-spreading fire in his kitchen at 375 Gotham Street. The quick-thinking dispatcher immediately rerouted the fire engine that was already driving to the area to Mr. Donino, and they put out the fire. 1 hour later, Mrs. Middling's cat fell out of the tree and bruised its coccyx, and unfortunately, Mrs. Middling is now suing the city for damages. We pointed out to the teams that there's obviously a requirement to dispatch resources based on severity, without leaving other incidents hanging.
We asked them to model this more specific requirement and also to pick up one quality requirement that they heard and to think about how it will be important to this scenario and then show it and communicate it in their model. Each team was given 10 minutes to present their solution in front of the live audience. Just as the plain old text and rich pictures modeling teams were voted into the final round, the doors of the auditorium burst open and a new stakeholder walked into the scene with yet another challenge to address.
Excuse me, the Gotham City Police Department needs to share the emergency dispatch system with you, Smokey. It isn't just a fire engine dispatch system. You can't go ahead and get it built to suit only your needs. What about us? Modelers, what if I tell you that every time a call comes in and a fire engine gets dispatched, we also need to send a police car to the scene to protect the public and investigate any criminality? I know that we don't always share the same information and communicate as well as we could, so we need a system that will help us communicate directly with each other rather than always go through central dispatch. It's too slow and error-prone. We're often much faster on the scene than the fire trucks, and we can pass on critical information to moderate or escalate the response. What if we arrived on the scene at Mr. Danino's kitchen and found that the whole block was on fire? We need the ability to interject. Equally, we could have sent a squad car to Mrs. Middling to help keep her calm, and perhaps we could have helped avoid that ugly legal situation. Show me how you can account for the role and needs of the GCPD in your model.
With a mere 10 minutes of the session remaining, the two surviving teams modelled and prevailed under pressure. Ultimately, the audience voted to call it a draw. Requirements engineers live and breathe models. As a community, our repertoire of modeling languages and notations is abundant. These range from formal specification languages to the structured use of natural language text, from the diagrams of the UML to the distinct graphical notations associated with ISTAR or the URN. Of course, sometimes nothing surpasses the value of a quick freehand sketch on the back of an envelope to express our understanding of stakeholder needs. Our next top model session represented an initial attempt to interactively compare different approaches to modeling. Not only was the session greatly entertaining, but subsequent discussion among participants delivered a clear message. First, we all agree that it's an oversimplification of the issues to believe that a single modeling technique is sufficient for all projects. We need to understand the nature of the problem and the skill set of the stakeholders to select appropriate techniques. Second, although we constrained our contestant teams to each use one and only one modeling technique, a more effective solution on any single project will almost inevitably involve a combination of techniques, at least one of which is likely to be text-based. What impedes this very obvious message is that as yet, we don't readily know which modeling approaches to use for what purposes, at what times, and in what ways that will combine them seamlessly in support of requirements engineering activities. Of paramount importance is ensuring that any technique or combination serves its purpose of communicating the requirements to the project stakeholders, who can then validate them and use them to design, implement, test, and maintain a system. In the best of circumstances, people tend to select modeling techniques with which they're already familiar and that intuitively serve this purpose without introducing unmanageable ambiguities. In practice, many projects default to the exclusive use of text in the form of shall statements or written scenarios simply because people aren't well versed in the use of a more diverse set of modeling techniques, and text is the common denominator. As educators, it's important to teach our students and to train our employees to use a variety of modeling techniques so that they have a toolkit from which they can select an appropriate solution for different situations. To this end, it's relatively simple to transform a classroom into a modeling workshop by using whiteboards and flip charts. Then you can challenge students to model a problem situation and possible solutions using a guided selection of techniques. The exercise we've described here provides an ideal forum for exploring the scope, strengths, and limitations of what's currently offered. In the written version of our column, we've provided all of the scenarios that we use to seed our modeling adventures. Please feel free to use and extend them as you see fit. To better understand how our models could and should share the RE catwalk, perhaps the next step should be to think harder about how we can capitalize upon our modeling experiences and gather the empirical data that Terekhov is seeking.